Hey class, Absolute 5 here today. So today I have great news. We're gonna finish, today is gonna be the last video for calculus, and then we can now go back to the very beginning because I wanted people to, well, this video I made for myself specifically, this video series of calculus, I made it for myself specifically because I don't want to forget calculus for the fact that I haven't practiced it in years. That's the whole reason why I started this whole series. But I will go back to the very fundamentals, so this way in the future students will be able to look back at these videos, well, even these ones as well. They were very helpful anyway, in my opinion, and also for students as well, they're going to use these videos anyway to help them out in the future. Now, enough deviating from what we're doing today. We're finishing up calculus, doing pretty much the rest of the antiderivatives. So then you'll have all the tools, and then after I finished the basics, eventually I'll go back to calculus 2, which will be integrals, but we won't be touching that topic anytime soon. So let's get right into what we're talking about right now. So antiderivatives. So let's draw a little bit of a chart, sort of the functions that we're going to be talking about. And these are particular, the reason why we say particular antiderivatives, because not all of these antiderivatives are, there isn't always going to be an antiderivative for a derivative, because they get so complicated to the point that it's almost impossible to know every single antiderivative. But that's why we have, we utilize some of these references here as antiderivatives. They're like kind of like the fundamentals of the antiderivative that you're going to need to know how to do. Where n does not equal to -1, so then we have x to the n plus 1 over n plus 1. This was a power antiderivative that we did yesterday. Well, we did it in the last video, I should say. Not yesterday, but. Then we have some trigs, we have sine, because the antiderivative of cosine is sine. This is where it's going to get a little tricky to remember. Because you would think the antiderivative of cosine, it would be just be sine, that would be fine. But then you would think the antiderivative of sine would simply be cosine, not negative cosine, but it is negative cosine. Because if you were to differentiate this as cosine, you'd get back negative sine. But that's not how you go backwards. You want to be able to get, remember, the antiderivative allows you to go forward and able to come back. Well, mainly come back, more or less. I'm going to continue here. So this is also a function, and then the antiderivative. So this function here is secant square, and you get tan x. Then you get secant x times tan x, which is just simply secant x. So those are the particular derivatives. So these are the functions, this is also functions, and then you have the particular antiderivatives for these functions. So let's get a really messy one, but we get to see how we apply each antiderivative in each technique, and see how we resolve this issue. Just understand that when it comes to these derivatives or antiderivatives, you have to understand that these are techniques, but nonetheless manipulations, and you can only be good at these things if you know the fundamentals of math, which is the fundamentals of the basics, which we will get over when we're done with this. Anyway, so let's continue this. No, sorry. Example. Let's say our derivative already is g prime, which is 4 sine of x plus 2x to the 5th minus root x all over x. Now, the question will say find g of x, meaning it's asking you to say, like, here's your mess. Here's what you started off with. And you're like, how in the function did I get this mess to begin with? So that's why you have the antiderivative to go back in time and say, hey, what's going on here? What happened? How did we get to this point? You know what I mean? It's kind of like those reverse stories that you see the ending before you see the beginning. So anyway, we're going to go back in time. So g of x, right? we still have 4 sine of x, but before we do the actual antiderivative, we're going to do some algebra. So it's 2x to the 5th minus root x all over, well sorry, not all over, but we're going to break up this denominator into each numerator. So now this is still some algebra here, we've got to manipulate this thing. With the law of exponents, you get to subtract the 2 exponents, we get x to the 4 minus. So now here's the thing, we can change the square root symbol to be x to the 1/2 all over x to the 1, because there's always a 1 there. When you subtract these exponents, you'd get x to the 1/2 minus 1, which is just going to be x to the negative 1/2. But we know we can't have a negative exponent, so we bring it down to the denominator to become x to the 1/2, which is just simply 1 over root x. So then we're left with 4 sine of x plus 2x to the 4. Well, I actually kind of went ahead of myself. Let's keep x to the negative 1/2. There's a reason for that. Negative x to the 1/2. Why? Because it's in the form of a power. So now we can apply the power rule for the antiderivative. So that's why we're doing that. So now let's move the constant out of here. So what's the antiderivative of sine? This is going to be, not cosine, negative cosine plus 2x. So remember, when you do the antiderivative, instead of moving to the front, you have to add 1 on top, and with that same value, you divide by that value. Or if not here, you'd get 4 plus 1, which is still going to be 5. Minus, so x to the negative 1/2. When you add 1 to this, negative 1/2 and add 1, it's going to be 1/2 over negative 1/2 plus 1. We're going to put this on top. So then, you use the algebra, you get what? Negative 4 cosine x plus 2 over 5 x to the 5th minus 1. Remember how this is 1/2, sorry. So then this is, let's see. Right. X to the 1/2 all over 1/2. But we know we can do the reciprocal of that. So then I'm just simply left with my g of x, that was like a 6. My g of x is going to be negative 4 cos x plus 2 over 5 x to the 5th minus 2 square root x plus some constant c. There we go. So you understand that to be able to, always remember this. Whenever you're doing math in general, as you go higher up the ladder of math, think of it this way. You are always using what you were taught from the beginning and continuing forward. One of my professors told me that it's like a snowball effect. When you start with a tiny little snowball, you roll it up and you roll it down a mountain full of snow, it gets bigger, it accumulates, and it gets bigger and bigger and accelerates at a very fast pace to the point that it becomes a ginormous ball of snow. That's how math is. You never forget what you were taught from the beginning. You always are interchangeably using what you were taught from the beginning, okay? So that's the lesson for you guys, and that's the end of calculus, so good for you guys. And then now we're going to eventually go back to the past and understand how the basics work. So this has been Absolute 5. I'm Raja Palomino. Don't forget to like, share, and subscribe to this channel. And be sure to smash that bell button to make sure it rings in your ears. And I will see you guys tomorrow with another video. So take care, guys. Remember, math is infinite because there are infinitely many possibilities.